Hello, I'm Chad Germany, and this is a continuation from my last video. I'm basically going to do another problem. It's the B problem that a lot of people, I think, missed on the test. It was pretty difficult. It's a difficult concept to understand. Paul Yoon used the chair business going on, but I'm actually going to use an actual B right there. There you go. And the question asked, how many different bracelets can you make using 12 different colored beads? And basically, these are the beads, and the difficult part about this isn't, just doing 12 factorial, because that's what it is. It's 12 factorial different ways you can arrange this. It's like having little different spaces, like you would any other problem. And saying that, oh yeah, this is 12, and then you choose from that 12, and then you got 11 left, right? And you have different mental ways you can choose from that 11, and then once you choose one from that 11, you get 10, and then so on and so forth, and it ends up being 12 factorial. But then you also have to account for something. You're not accounting for the motion. This thing can move around. Say, for instance, you have Lady Guadalupe right here. Lady Guadalupe, and she's number 1. You turn this around this way, rotate it clockwise, and she becomes number 2, beat number 2. And then you rotate again, she becomes beat number 3. And this can happen 12 times. Eventually you rotate around until you get back to her. Okay? And so you have to count for that. You have to divide by 12. You see? In this process, you have to divide by 12 right there. Okay? But that's not the end of the story, because it can have an order this way. Say if this is number 1, this is number 2, number 3, and so on and so forth. 12 factorial divided by 12 doesn't account for this thing being able to flip around. You can flip this. This is one bracelet, okay? This is one bracelet. And you flip it around, and you can change the sequence of it. You're constantly changing the sequence once you flip it around. So you have to account for that, and you do that by dividing it by 2 as well. So you end up having 12 factorial divided by 12 times 2, which is the answer. Yeah, it's a difficult concept to understand, but, just practice with your bracelets, right? Use a Jesus bracelet. Okay, what other problem do I have? Better hurry, I'm running out of time again. Well, let's try this problem. This is a neat problem to look at. I want you to see if you can understand it. I couldn't word it correctly, so just see if you can understand what I'm saying. I'm basically saying that if a lazy student wants to take the math contest exam, and if you guess on a problem, you get minus 1/4, right? If you get it right, you get a point, obviously. And this is utilizing game theory, and I'm going to show you how to do it. Okay, say for instance, you want to set up a table. You have a table like this, right? Give you closer a little. Alright, okay. And then you have the probability of whatever, okay? And then you have the points, okay? You have the points taken away and the points added, okay? And then right here, you obviously times it. I'll tell you about that later. But anyway, okay? How many points do you get? If you get it right, you get what? 1 point. Positive 1, right? Positive 1, right? If you get it wrong, then you get negative 1/4. These are actual numbers, okay? They have the same thing on SAT too. SAT. Okay. So it's 1/5. The probability is 1/5 because there's an A. In these types of problems, there's an A, there's a B, there's a C, there's a D, there's an E. Okay. Let me show you the actual exam. if I have it, if I can find it. Okay. It's kind of taking a long time to find it. Let me see. I just had it. Where'd it go? I don't know where it went. I just had it. I just was working on a problem. Oh well, sorry. I can't show it to you. I'll show it to you later. Sometime later. Okay. Well, basically, it's A, B, C, and D. A, B, C, D, and E. Okay. So you have a 1/5 chance of getting the right answer. So therefore, using this rule right here, that the conjugate or the complementary probability will be 1 minus that, which is this. It makes sense because if the answer is answer is B, and you could get A, get C, D, E, and they all add, their probabilities add together, and basically you end up having 4/5. Okay, and so it looks like this basically. All right, so you do the appropriate operation and times it by each other. So you have 1/5 right here on this side. Let's make it darker. You have 1/5, and then you times this side, and then you have 1/5 on this side. What do we know? Our expected value is the sum of these two values, which is 0. So it makes sense for them to minus 1/4 for every answer you get wrong, because you have no benefit for guessing. Because if they didn't do it, then okay, just like say if this is 0 right here, say if this is 0, okay, you times it by that, this is 0. So there actually be a benefit of plus 1/5 points for guessing, which is unfortunate. But they fixed the problem. So this is implemented in the SAT, like I said, and in the math contest test, which is very, very difficult. Okay.